You're watching robots that can outfight, outrun, and outplay human athletes. China's been engineering machines that master every sport we've invented, and the performance numbers are about to blow your mind. These aren't clunky experiments anymore. They're precision-built athletes with reaction times and power outputs that make Olympians look slow. And the most terrifying part? They're just getting started. But before we get to the speeds that break records, let's talk about the robots built to fight. Picture a humanoid robot throwing punches at 70 miles per hour. That's the Unitree G1, and it's not just swinging randomly. This machine has 35 degrees of freedom across its body, meaning 35 independent joints working together to deliver strikes with professional boxer precision. Each arm is powered by servo motors, generating enough torque to punch through drywall, but controlled down to the millimeter to stop exactly where it needs to. The engineers programmed it using motion capture data from actual martial artists, so every jab, every block, every defensive stance comes from real fighting technique translated into machine language. Then there's the Walker S Humanoid. This robot doesn't just punch. It kicks with 1,200 newtons of force per leg, enough to send a heavy bag flying. The feet have pressure sensors that detect weight distribution in real time, adjusting balance faster than your brain can process what's happening. When it throws a roundhouse kick, gyroscopic sensors in the torso keep it from toppling over, compensating for the rotational force in under 10 milliseconds. But here's where it gets really insane. These robots react in 3 milliseconds. 3. A human blink takes 300 milliseconds. By the time you've registered a punch coming at you, these machines have already seen it, calculated the trajectory, and moved to block. They're running predictive algorithms that analyze body positioning and predict the next move before it happens. It's like fighting someone who can read your mind, except it's just reading physics. In sparring demonstrations, the G1 has blocked 92% of incoming strikes, not because it's stronger than a human fighter, but because it's faster where it counts. The engineers aren't trying to build knockout power. They're building reaction speed and precision. And watching these robots spar with professional martial artists is genuinely unsettling, because the human has to think while the robot just calculates. But fighting isn't the only sport where machines are beating biology. Now, imagine a robot that never misses a free throw. Chinese engineers built basketball-playing humanoids that sink shots with 94% accuracy from 15 feet. That's better than most NBA players. The secret isn't in the arms, it's in the vision system. These robots have dual cameras in their heads, running object recognition at 240 frames per second. They calculate ball trajectory, distance, and arc in under half a second, then execute the perfect release angle every single time. The shoulder joints rotate through 180 degrees with brushless motors that deliver consistent force down to the newton. No fatigue, no pressure, just math and mechanics. Soccer robots are even more impressive when you see them in action. Humanoid robots like the Walker X and Unitree H1 have been adapted to play soccer with precision that's genuinely unnerving. They dribble using force sensors in their feet that detect exactly how hard to tap the ball. Pass accuracy sits at 87% over distances up to 30 feet. And they read the field using vision systems that map every player's position in 3 dimensions. When they take a shot, the ball leaves their foot at 45 miles per hour with spin calculated to curve around defenders. Then there's table tennis, and this is where reaction time becomes everything. The Morpheus robot system returns shots with 96% accuracy against championship-level players. The paddles have accelerometers that measure swing speed and angle in real time. Vision systems track the ball's spin by analyzing rotation patterns at 500 frames per second. The robot predicts where the ball will land before it even crosses the net, positioning itself with robotic arms that move through their full range in 0.2 seconds. But the real engineering challenge isn't individual performance, it's coordination. Getting multiple robots to work together as a team requires wireless communication protocols running at gigahertz frequencies. Each robot broadcasts its position and intention 20 times per second. Spatial awareness sensors create a shared map of the playing field, and collision avoidance algorithms keep them from crashing into each other while chasing the ball. In demonstrations, 3 basketball robots ran plays with timing precise to within 50 milliseconds. That's team coordination tighter than most human squads achieve. The payoff? In controlled scrimmages, these robot teams score at rates that match college-level human athletes. And they're improving every single season. But speed is where robots really leave humans in the dust. Usain Bolt's top speed was 27.8 miles per hour. The Unitree G1 humanoid robot hits 12.4 miles per hour on 2 legs. That might sound slower, but here's what makes it terrifying. Bolt took years of training to reach that speed. The H1 got there through engineering in 18 months. And the next generation prototype is already clocking 15.5 miles per hour in lab tests. The secret is in the legs. Each leg has 12 actuators working in perfect synchronization. These aren't simple motors. They're high-torque servo systems that generate 340 Newton-meters of rotational force. The knees bend through 120 degrees of motion, and the ankles have active suspension that adjusts ground contact in real time. When the robot's foot hits the pavement, pressure sensors detect the impact force and instantly calculate the optimal push-off angle for the next stride. It's running on physics calculations happening 1,000 times per second. Then there's the Star 1 robot, and this machine was built specifically to break speed records. It weighs 143 pounds, but runs with a stride length of 4.2 feet. The hip joints use a new type of actuator called a quasi-direct drive system. Traditional motors have gears that create friction and waste energy. Quasi-direct drive eliminates most of that, converting 87% of electrical input directly into mechanical motion. That efficiency means the Star 1 can sprint for 12 minutes straight before its batteries drain. But here's the engineering challenge that almost broke the development teams. Balance at high speed. When you're running at 12 miles per hour on 2 legs, your center of mass is constantly shifting. Fall forward by 3 degrees and you're eating pavement. The solution? An IMU, an inertial measurement unit, mounted in the torso. This sensor detects tilt and rotation across 3 axes, feeding data to the balance algorithm 600 times per second. The robot makes micro adjustments to its leg positioning faster than physics can pull it down. And it's not just straight line speed. These robots navigate obstacles while running. The H1 has cleared hurdles 18 inches high without breaking stride. Vision systems map the terrain 15 feet ahead, and the leg controllers pre-program the jump trajectory before the robot even reaches the obstacle. Ground contact time per step is 0.15 seconds. That's how long each foot touches the ground before launching into the next stride. For comparison, elite human sprinters manage 0.1 seconds at peak performance. The most insane part? Engineers are targeting 20 miles per hour for the next model. They're redesigning the knee joints with carbon fiber components that weigh 40% less while maintaining the same strength. Lighter legs mean faster acceleration and higher top speeds. The math says it's possible. The prototypes are already in testing. But all of this speed, all of this ball handling precision, all of these combat capabilities, they come together in one place. Every year, universities and tech companies bring their best athletic robots to compete head-to-head. This is the Chinese Robot Games, and it's where you see just how far this technology has actually come. The events read like the Olympics: 100-meter sprints, obstacle courses, basketball shooting contests, and full-contact combat matches. Except the athletes are machines, and the performance numbers are getting scary good. In the sprint category, robots line up on a regulation track. The current record sits at 11.2 miles per hour over 100 meters. That's a 40-second 100-meter, which sounds slow until you remember these machines are running on 2 legs with 0 evolutionary advantage. The winning robot this year used a new ankle design with 3-axis rotation instead of 2. That extra degree of freedom let it push off the ground with 9% more force per stride. 9% translated to shaving 3 seconds off its previous time. The obstacle course is where engineering gets creative. Robots have to climb over walls, crawl under barriers, and jump across gaps. The Unitree G1 took first place by completing the course in 2 minutes 14 seconds. Its secret? Reinforcement learning. The engineers didn't program specific movements for each obstacle. They let the AI practice the course 10,000 times in simulation, learning which joint angles and timing sequences worked best. By competition day, it moved through obstacles with efficiency that looked almost organic. Basketball shooting competitions measure pure accuracy under pressure. Robots get 30 shots from various positions around the key. The top performer landed 28 out of 30, including 6 three-pointers in a row. The vision system on that robot samples the basket position 40 times before releasing the ball, compensating for even tiny movements in its own stance. Release timing varies by less than 5 milliseconds between shots. Then comes combat, and this is the event everyone watches. 2 robots enter a ring and spar for 3 two-minute rounds. Points are scored on clean strikes and defensive blocks. This year's champion was a modified Walker S with upgraded torso stabilization. It won by landing 63% of its strikes while blocking 78% of incoming attacks. The reaction time advantage was brutal to watch. Its opponent would start a punch, and the Walker S had already moved to counter before the strike was halfway through its arc. But here's what really matters about these games. The performance gap is closing fast. 3 years ago, the winning sprint time was 52 seconds. Now it's 40. 2 years ago, basketball accuracy averaged 71%. Now it's over 90. The robots aren't just getting better. They're improving at an exponential rate that human athletes can't match. And the engineering breakthroughs happening in these competitions? They're feeding directly into next-generation designs. The ankle joint that won the sprint event is already being integrated into commercial humanoid platforms. The vision system from the basketball champion is being licensed to 3 other robotics companies. Every competition pushes the entire field forward. Right now, the fastest humanoid robot runs at half the speed of Usain Bolt. The best robot basketball player shoots better than 80% of college athletes. Combat robots react 3 times faster than professional fighters. And in 5 years, engineers are projecting speeds of 25 miles per hour, shooting accuracy above 98%, and reaction times under 2 milliseconds. At that point, you're not watching robots try to keep up with human athletes. You're watching human athletes become obsolete.